Welcome to solverfy.
This is the answer to Chapter 27, problem number 6 from the Smith Organic Chemistry textbook. And in this problem, we are asked to draw the product of two different paracyclic reactions with regards to the stereochemistry that is developed in the products. And so the main rule that's going to govern the stereochemistry of these products is going to be what I've written at the top of the page here, which is that in a conjugated polyene, meaning multiple double bonds, in a conjugated polyene, if there are an odd number of double bonds, then there will be disrotatory rotation. And if there are an even number of double bonds, there will be conrotatory rotation. Disrotatory means that the two carbons in question rotate in opposite directions. Conrotatory means that they rotate in the same direction. And so to look at these two examples, for A, we see that in our conjugated diene, we have an odd number, or pardon me, in our conjugated polyene, we have an odd number of double bonds. And so when we draw the movement of these electrons, and I will draw that just briefly to make it a little easier to visualize. So the electrons are going to move around. Remember, this happens as a single step. These electrons will form the new bond. And so we've closed the ring here. So this product is going to have a closed ring. It will have two double bonds there and there. And then these two methyl groups are going to rotate in different directions. So they are both flat in the page in the starting material. And in the product, we will draw them cis because one rotates to the clockwise and one rotates counterclockwise. And so they both end up cis to each other on the same side of the molecule. Now, in our second problem here for B, our starting material actually is not a polyene. It's just an alkene. There's only one double bond. So we need to think about this in terms of the product. So what's going to happen here when this is exposed to some heat, this double bond will move and this single bond will break. And so our product is going to look like this. So that hasn't really changed. And then we have a double bond here where formerly we had a single bond. And we have a double bond here where we also formerly had a single bond. And so in that system, we have an even number of double bonds. And so the two carbons that we're going to look at, which are this one and this one, are going to rotate. Their orbitals are going to rotate in a conrotatory fashion. So they're both going to rotate the same way. So if we picture them rotating up, as it were, we will get that trans stereochemistry around that double bond. And then there, that carbon is also rotated up. So that methyl group is also pointing up now. And so that's actually going to be cis stereochemistry. So they rotate in the same direction, and here they end up one trans and one cis. And so that is the answer to Chapter 27